So our problem states that we have a submerged scuba divers, or a scuba diver hears the sound of a boat horn directly above her on the surface of the lake. At the same time, a friend on dry land 22 meters from the boat also hears the horn. So please refer to the figure below. The horn is 1.2 meters above the surface of the water. What is the distance labeled as question mark here from the horn to the diver? And both air and water are at 20 degrees Celsius. Now over here are some values which we might find helpful in our calculation. So firstly, we have different speeds of sounds in different medium, and our interest is in air at 20 degrees Celsius, that's 344 meters per second, and in water at 20 degrees Celsius, that is 1482 meters per second. Now, to simplify this problem, it would be very helpful if we can simply provide a simple sketch. So as you can see here, I have over here a horn which emits the sound, and that sound has to travel to my distant friend, which is 22 meters away from me or away from the horn. And then that same sound emitted by the horn has to travel in air to the surface of the water at a distance of 1.2 meters. And that same sound also has to move through a different medium, in this case, the water, to reach the scuba diver. And that distance is something that you have to solve for in this problem. Now understand that the person on the dry land that is 22 meters away hears the same sound emitted by the horn. So from this, you can solve for the time it took for the sound wave to reach this person. So basically, the horn is emitting the sound, and the person 22 meters away from that horn hears it, and from there we can actually solve for the time it took for the sound wave to be heard by that person. So how do we do that? Simply, we take into consideration the equation for your velocity, or simply the magnitude of the velocity, which is just speed. We take it as the distance traveled by the sound wave divided by the time it took for the sound wave to travel in that distance. So rearranging this equation, we get an expression for time. And take note that the time that you can solve for this is the time taken from the horn, or it took for the sound wave to move from the horn to the person on the dry land. So that is just the distance, which is in this case is 22 meters, divided by the velocity of the gas. Now recall that previously we were able to see the velocity of a gas, and that is 344 meters per second at this temperature. So we are dealing with 20 degrees Celsius. Now simply plugging in the values, the distance is 22 meters, the velocity is 344 meters per second. So that will give you a time of 0.064 seconds. So what this means is that from the horn up until the person on the land, the sound wave travels in the medium of air for 0.064 seconds before it was heard by that person 22 meters away. And that realization is very central to solving this problem, because you have to remember that the scuba diver below hears this very same sound at also the same time interval of 0.064 seconds. And you have to understand that the horn, or the sound produced by the horn, has to travel some distance t in order to reach from the air to the top surface of the water. So that means to say then that we have to solve the time t, which is denoted by capital T, and this is simply the time taken from the sound wave of the horn to reach just the surface of the water. And we are still moving in the same medium. In this case, the medium is air. So we are still going to utilize the same equation. The velocity of the gas is simply the distance traveled, in this case that's 1.2 meters, over the time. So we are going to solve for this time t. So rearranging that equation, we get an expression of Time is simply time is simply the distance divided by the velocity of the gas. And take note, the velocity of a gas at 20 degrees Celsius is given to be 344 meters per second. So when you substitute all of that values, you get a value of time which is 3.49 times 10 to the negative 3 seconds. It means to say that this is the time taken from the horn over here up until just the surface of the water. So if we are going to look back in our original figure, that is just from here up until here. So the sound needs to travel in this time interval. Okay. But then again, we have to realize that from the horn up until the scuba diver below, it took the same time of 0.064 seconds to reach the scuba diver as well as to reach this distant person over here. So that means to say then that in order for us to solve for this question mark distance, we have to firstly determine the time it took for the sound to travel simply on the new medium. In this case, just the water, meaning the time it took for the sound wave to travel on the water portion. So how do we do that? This means that the sound wave travels in the new medium, in this case, the water, for a total time of 0.064 seconds minus 3.29 times 10 to the negative 3 seconds. So over here, I'm sorry, it should be 3.49 times 10 to the negative 3. So kindly note of this one. So when you do that calculation, you get 0.06051 seconds. What this means is that your sound wave from the new medium, the top portion of water, to the scuba diver below has to take this time interval before reaching the scuba diver below. So this one or this value is very important because from this, we can now solve for distance traveled by the sound wave. And how do we do that? So this is not surprising. We deal with the same equation before. You take that the velocity is simply on the water, which is the new medium, is just the total distance divided by time t. Now, in order for you not to interchange the values of time, I purposely have it in all uppercase to indicate that this is the time on the new medium, in this case, the water. So we have to derive an expression for distance because that is what we are going to find for in this case. So when you try to manipulate your equation, you end up with distance is equal to the velocity in the water times time. And then if you remember earlier, the velocity of water at 20 degrees Celsius is 1,482 meters per second. And then the time t in this case is simply the time at the new medium, so water, to reach your scuba diver. So from here, you can solve for distance, and that is given to be 89.67 meters. Now going back to the sketch, that means to say that from the surface of the water up to the scuba diver, that is simply 89.67 meters. Okay, so but we have to go back a little bit to our problem over here. So a little bit of rewind. Take note that the problem asks, what is the distance traveled, or what is the distance labeled by question mark from the horn to the diver? So that means to say from the source of the sound to the diver. And I would just like to emphasize very well that what we had just solved is simply 89.67 is simply the distance from the top surface up until the scuba diver. Or simply in this illustration, just the red part. So since the problem asks from the source up until the scuba diver, so we have to take into consideration that the time, or I mean the distance that we should get or solve for should be the total distance d given by this equation. The distance on the water to the scuba diver, and then you add the distance above the water. What I mean by above the water is from the horn up until the surface of the water. So simply that is basic arithmetic. So that's 89.67 meters. This is from the top surface of the water up until the scuba diver. And 1.2 meter is from the horn to the top of the surface of the water. That's 1.2. So when you add that one, you get a total distance of 90.87 meters. And that is how you solve this problem.